Next generation embedded Linux. We now support Ubuntu. So just a little bit about how this went. The docs now contain a module Ubuntu page under the distribution section. And this was very similar to Debian. It turns out a lot of the infrastructure is the same. The packaging mechanism is the same. We were able to use mmdebstrap to build the image, and that all worked pretty well. One of the big differences is Ubuntu uses a different compression mechanism, Z standard or something like that, and we ran into a little bug with that, but that was able to be fixed. And yeah, basically it's just a parallel version of Debian, and a lot of the stuff just pretty much works the same. So let's take a look. So we'll fire up Yo. And currently we're set up for the Debian distribution, so let's hit S for settings, go down and select Ubuntu. Let's find the dev image. Okay, so it's a few more packages, like 211 packages to build this development image. If we scroll down through, let's sort by package size just to get an idea what's taking up space. Yeah, so this is interesting. So the image is approaching 1 gigabyte, and some of the bigger packages in this system are actually things like firmware and so on. So a lot of this could no doubt be trimmed out for an embedded image where you're not using all this Qualcomm firmware and other things. Yeah, this looks like it's just kitchen sink, everything you'd ever need for any system. So yeah, lots of opportunities to trim this down and clean it up. If we tab over to the modules page, we now show the Ubuntu module. And down here under feeds, we can see that Ubuntu main exposes a little over 6,000 packages. And we still need to add the Ubuntu community and things like that, but the main has enough stuff that we were able to at least get a base image running. So let's boot this up. I'll type R for run. This will launch QEMU. And we're in. If we look at the kernel version that's running, let's cat proc version, we can see this is Ubuntu standard kernel built by Ubuntu. And in the near future, we're going to play around with custom kernels because that's really what we want to do with embedded systems. Let's see, what else do we want to look at? With Yo, it's very easy to build this development image for multiple distros. We've been mostly working with the TUI, but let's jump out to the command line so we can do a Yo build -distro. Let's do an Alpine dev image. And everything's cached, so it shows we built 78 units. We can do the same with Debian. 176 units. And Ubuntu. So this kind of shows how all three distributions are coexisting in one build system. If we take a look at the build directory, we have a different directory for each distribution. The same with a package feed directory. This is the project is YoTest, but under there we have an Alpine feed, a Debian feed, and an Ubuntu feed. Notice the Debian and Ubuntu look very similar. So this has been encouraging. It shows that you know, it's not a lot of work to support multiple distributions with this build system. And we are still building a number of packages in core. Let me just select on that. So let's do select module core. So in this Ubuntu build, we're still building bash, core util, CS certificates, file, a bunch of stuff out of core. We wouldn't have to do this because all these packages we could get from the Ubuntu feeds. And if you're doing a real production image, you probably want to pin these to Ubuntu because, you know, and have use their packages. But the reason I'm doing this now is I want to exercise the ability to mix source packages, our own source packages, into this Ubuntu build. And this is just a way, we'll probably eventually back this out, but this is a way to you know, just kind of exercise the whole mechanism, make sure everything's works, because we are using a lot of Ubuntu libraries to build these. So if you go in and look at curl, for instance, oops, core, let's go in and look at the curl. If we hit G to go to the top of the build log, we can see that there are a lot of dependencies to build curl. And a lot of these dependencies actually come from the Ubuntu libraries. So if we go into the curl directory, let's hit $sign to shell into that. And this is currently the source directory, but if we go up one layer, we're now in the build directory. We can look in sysroot, and there's a lot of stuff that gets pulled in here. Let's just do an ls sysroot, and we can see that there's really a lot of libraries, a lot of infrastructure things that get libraries that get pulled in, and these are all pulled into the custom sysroot for this package that allows us to build. And what we do during our build is we actually run this with a bubble wrap in bubble wrap, so that it only sees what's in the sysroot, so that it ensures that we have our dependency specified and we're not reaching out into our host system or into other libraries to pull things in that we need. So this is a lot how Yocto does things. That's where these ideas come from. And anyway, it's working out really well. So let me know what you think, and probably the next focus will be getting some of this stuff exercised on real hardware instead of QEMU. Thanks.